In this video, we will have a rundown on another Anki deck that I've created back when I was in grade 11. That was more than a year ago. So this is second quarter chemistry. I remember taking the exams for this back in January 2023. We'll start now. Okay, so in these kinds of questions, I'll just leave it to you. So this is the answer. Because this is easier to do, to solve if I'm using the iPad, but that can't be the case right now. And besides, I've already made a video on this before, more than a year ago, back when I was in grade 11. So yeah, we'll just skip that question. Classify the following reaction. So we have an aqueous, two aqueous solutions here. Solid and aqueous in the other side. Well, double replacement. How is this double replacement? Well, as you can see here, sodium, it goes with chlorine. The chlorine used to be with calcium. And the calcium is now with the CO3 that Na used to be with. So, yeah, AB plus CD is equal to AC plus BD. Something like that. The absolute mass of a single atom can be obtained by dividing the molar mass of that atom by Avogadro's number. What is Avogadro's number again? It's a specific value, 6.023 something. 6.02 times 10 raised to 23. How many moles are present in 10 grams of sodium hydroxide or NaOH? Usually, you need to compute for this. So, we need the atomic masses of sodium, oxygen, and hydrogen. Basically, all the elements that are in this substance. So, for sodium, we have 23 grams per mole. For oxygen, the atomic mass is 16, hydrogen is 1. So, in order to determine how many moles are present, you just find the sum of these values. So, 23 plus 16 plus 1, that equals to 40. Answer is 40 grams per mole. Okay? 0.25 moles of magnesium contains how many atoms? So, this is supposed to be the solution. Let's see. Well, that's frustrating. How do we unblur this? I can't seem to unblur it. If ever there was a way, I am not familiar on how to do it. Screw this question. Can we just ask the internet? But essentially, we're gonna use Avogadro's number here. Could have been a lot easier if we use an iPad to compute manually. Okay, so I think this is the answer. Let's just check someone else's solution. Okay, so basically we multiply the moles, the mole value, that's 0.25, with Avogadro's number, that's 6.022 times 10 raised to 23. And the answer is this one. So it's similar, although it's pixelated. You can see that it resembles 1.51 times 10 raised to 23. Okay, next question. Okay, the answer is also here. What is the molar mass for aluminum? Well, atomic mass is what? What's the atomic mass of aluminum? 26.9. Say 27. 26.982. Let's confirm. Is molar mass the same as atomic mass? Will they have there's a distinction? How about in terms of value? We'll leave it at that. Because from the previous question, we were given a problem where we have to solve for the molar mass of a substance that contains 3 distinct elements. So we just find the sum of the atomic masses of those elements and we get the molar mass. So in this scenario, well, we only have aluminum, it's just a single element. So knowing its atomic mass, we also find the molar mass. So that's 26.98 grams per mole. Okay, calculate the molar mass of sodium bicarbonate. Let's just see the answer. Sodium's atomic mass again is 23. For hydrogen, it's 1. For carbon, it's 12. And for oxygen, it's 16. So just find the sum. 23 plus 1, 24. 24 plus 12, 36. 36 plus... well, let's keep 16. Sorry. Let's keep 36. Because, as you can see here, we have O3. So, we multiply 3 by 16. So there are 3 oxygen atoms basically. So 16 times 3, 48. 48 plus 36 is 84. As you can see here. 84.01 to be more specific. Okay. What is the molar mass of K3PO4? Is this? I want to know what this is in terms of its UPAC name. Tripotassium phosphate. Okay. As long as there's PO4 in the end, that's phosphate. If it's PO3, it's phosphite. Yeah, phosphite. Tripotassium. Yeah. So we know that potassium has an atomic mass of 39.1 AMU. AMU, by the way, is the unit of unit for atomic mass. Phosphorus is 31 AMU and oxygen is 16 AMU. So K3, so 39.1 times 3 plus 31 plus 16 times 4. So that amounts to 212.3 grams per mole. Okay, that's it. How many moles are there in 20 grams of iron chlorate? What's FeCl3? Iron chloride. Okay. How do we solve this question? Let's see the solution. So we have to gather first the atomic mass values. So for aluminum, it's 27. Wait a minute. Let's confirm. Is AMU the same as grams per mole? Turns out they are the same. So take hydrogen for example. The atomic mass is 1, or to be more specific, 1.01. The unit is AMU. It's the same as if you write grams per mole. That is the unit for molar mass. So it can be concluded here that atomic mass can be equal to the value of the molar mass. Okay, so even if I write AMU here, it's still technically correct. So, okay. Iron is... Where is iron here? Yeah. The question doesn't... Well, the solution doesn't match the question. My recommendation is we disregard this question. We just listen to this question over here. So what is the molar mass of Al2SO43? So aluminum is 27, sulfur is 32.07, oxygen is 16. We have 2 aluminums, so 27 times 2, plus we have, I think we applied distributive property. So the 3 will be multiplied to sulfur, so we have 3 sulfurs. That's 32.07 times 3, as you can see there. And the oxygen, 4 times 3 is going to be 12, so 16 times 12. You solve this, you get 342.21, or approximately in the choices, the closest answer is letter C, 342.17 grams per mole. Again, please disregard this question. There might have been a typo in this part. The molar mass of carbon dioxide is 23 daltons. False. So the molar mass of carbon dioxide is 44 AMU, or in other words, 44 grams per mole. 44 AMU is not equal to 26 daltons. What is daltons in the first place? What unit does that correspond to? Unit of mass. Okay. So it is clear that 1 dalton is equal to 1 gram per mole. Actually, I'll take note of that. It's very important. So 1 AMU is equal to 1 G/mol, and it's also equal to 1 dalton. Let's confirm. 1 dalton in AMU is 1 atomic mass unit is equal to 1 dalton. That is approximately, oh, there's a value, 1.66 times 10. What's this, minus? Okay. 1 AMU is equal to 1.66 times 10 raised to negative 27 kilograms. Okay, I'm finished taking note of it. Calculate the molar mass of aluminum nitrate, or AlNO3. Okay, atomic mass of aluminum is 27. The nitrogen atomic mass is 14. For oxygen, it's 16. If we simplify this expression, we're gonna have 3 nitrogens and 9 oxygens. So 27, that's aluminum, plus 14 times 3, because we have 3 nitrogens, and 16 times 9. Solve, we have 213 grams per mole. Or to be more specific, 212.996. This is aluminum nitrate. Next, which of the following is the mass of 1 mole of magnesium sulfate? Is this magnesium sulfate? MgSO4. Yep. Okay, how do we solve this question? Enlist the atomic mass values. Magnesium is 24.3, sulfur is 32.07, and oxygen is 16. 24.3 plus 34.07 plus 16.4. 16 times 4, because we have 4 oxygens. The answer is 120.37 grams per mole. Which alkaline earth metal has the smallest molar mass? Just looking at the values. The smallest is beryllium, I suppose. Is it? Yeah. Common sense. And the largest is barium. Yeah, barium. This is strontium. This is magnesium. This is calcium. Calculate the molar mass of calcium chloride. Is it chloride or chloride? Calcium chloride. How about CaCl only, without the 2? Anyways. The answer is... Okay, let's look at the solution first. The atomic mass of calcium is 40.1. The atomic mass of chlorine is 35.5. And we have 2 chlorine atoms. So 40.1 plus 35.5 times 2. That's 110.98. That's the answer. What is the smallest representative particle of an element? The atom, I think. Yeah. Number of atoms, or simply atoms. 1 mole of molecules of a substance is equal to the gram molecular mass of the element. The number of moles in 4.5 times 10 raised to 24 atoms of oxygen is what? How do we solve this question? I don't like this thing. Show answer. 7.5 number of moles. Let me just get my calculator real quick. I'll be back in 30 seconds. Alright. I think this is a solution. So, atoms of oxygen over Avogadro's number. I think that's the formula to use in order to find 7.5. Let's confirm if this expression amounts to 7.5. Yes, it does. 7.47508. Yeah, 7.5 approximately. So I guess that's a formula. Atoms of an element over Avogadro's number is equal to the number of moles. True or false? Avogadro's number varies according to the particles in 1 mole of a substance. Well, it is a constant in the first place, so it cannot change. Right? Yeah. False. Avogadro's number does not vary according to the particles in 1 mole of the substance. It is a constant. So it will always be 6.022 times 10 raised to 23. What is the molar mass of, what is this, lead? Pb? Is Pb lead? Let me confirm if I remember correctly. Yep, lead. The molar mass is the same as the atomic mass. What is it? 207.2 grams per mole. Oil of vitriol is a substance that humankind has known for thousands of years. Today, the substance is known by its scientific name, sulfuric acid, and has the molecular formula H2SO4. Sulfuric acid. What is the molar mass of sulfuric acid? Okay, so we have the atomic masses. Hydrogen is 1, sulfur is 32.07, oxygen is 16. We have 2 hydrogens, 4 oxygens, so the sum is 98.07. That's the answer. classify the following reaction. I think we've been here before. Na matches with this here, and CO3 here matches with Ca there, as you can see here. Double displacement or double replacement. Whether it's displacement or replacement, according to my teacher, well, they're practically the same. So there's no wrong answer if you choose either word. The absolute mass of a single atom can be obtained by dividing the molar mass of that atom by Avogadro's number. I think this is what we did in our previous question. The one where the answer was 7.5. So divide it by Avogadro's number and you get the absolute mass of a single atom, or the number of atoms. I'm not sure if they're the same, but yeah, we're trying to connect the dots here. Balance the equation. Okay, been there already. How many moles are present in 10 grams of sodium hydroxide? We've been here also. So just find the sum of atomic masses. Triple point versus critical point. I think it's better if there's a visualization for this. For triple point, this represents the combination of pressure and temperature that facilitates all phases of matter at equilibrium. For critical point, this is, it terminates the liquid or gas phase line. It relates to the critical pressure. This is the pressure above which a supercritical fluid forms. Okay, let's analyze this illustration. So in the y-axis we have pressure, and in the x-axis we have temperature. As you can see, it can be implied here that in terms of the relationship of pressure and temperature, well, the higher the pressure is, the higher the temperature. I think, wait, is that true? To temperature. I think we need to cite the ideal gas law. Okay, so the temperature of the gas is directly proportional to its pressure. But we're not just talking about gases here, right? So here, where there is where the temperature is lowest, we have solids. Critical pressure is here, critical temperature over there. Where there is a really high temperature, but we haven't reached anywhere above the critical pressure, we have a gaseous phase. But before we reach critical temperature or critical pressure, the substance is still either in liquid phase or they're in vapor form. So depending on the temperature, let's say the temperature is close to the critical temperature but not above, the liquid is compressible. But if it reaches above the critical temperature, then we have a supercritical fluid. This is the most unfamiliar to me personally. But yeah, triple point, critical point. What is the meaning of triple point again? This represents the combination of pressure and temperature that facilitates all of phases of matter at equilibrium. So I guess this is equilibrium, from how I understand it. Critical point terminates the liquid or gas phase line. Where is that? Over here. Okay, relates to the critical pressure, the pressure above which a supercritical liquid forms. Yeah, that's true. Such that you also locate yourself in being subject to critical temperature. That's when supercritical liquid forms. let's find examples of supercritical lipids. Okay. So I believe this is also helpful in enforcing what was stated earlier. So for example, water, it becomes supercritical with even more pressure and even more heat. So yeah. So if there's heat, there would be vapor. But if you place a lid, well, pressure would exist. So eventually it would be supercritical if there's a lot of pressure and there's a lot of heat. And as you can see, in order to keep the lid from, well, the tendency is, because of the growing pressure from inside, the lid would be carried by the water. So I think there's a reason why we have these, I'll call them joints, so that the lid doesn't open by itself. Okay. Pressure in terms of bar, temperature in terms of Kelvin, triple point, critical point. Okay. We've been here. What is the molar mass for aluminum? 26.98. Sodium bicarbonate, we haven't seen this yet. Sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16. We have 3 oxygens, so 16 times 3. We have 84.01 grams per mole. Okay, this is not chemistry. Avogadro's number is 6.022 times 10 raised to 23. Wasn't asking for the value. That's kind of funny. It is a constant irrespective of the mass of the gases. The gas mass doesn't influence the value of Avogadro's number. It does not vary according to the mass of the gases and the pressure on the gases. Blank is the amount of substance that contains 6.02 times 10 raised to 23 representative particles, whether they are atoms, ions, etc., of that substance. Mole. Okay. We've been here. Calculate the moles. Okay, so I'm not sure why this appeared. It's irrelevant to this question. Where's the solution? There's no solution. I'm afraid I won't be able to elaborate further on this. There should have been a solution paper here. At least an image of it. Boyle's law. From the... How I remember Boyle's law is basically you vote Boyle for vice president. Vice is volume, president is pressure. VP is equal to VP, such that it is implied from that equation that the volume is inversely proportional to pressure. Yes. So VP, vice president. Vote Boyle for vice president. Volume 1 times pressure 1 is equal to volume 2 times pressure 2. Blank is the number of protons in the nucleus of an atom. Atomic number. The value of Avogadro's number is 6.02 times 10 raised to 23. How many moles of chlorine atoms would be present in 1 mole of calcium chloride? 2. Why is there no solution for this? I can't elaborate further. Blank is the mass of one molecule of that compound. The unit is in AMU, molecular mass, or molar mass. Calculate the molar mass of iron oxide. Okay, oxygen is 16. I've been repeating the same number again and again, so naturally I've already remembered it. But for iron, it's 55.9. So 55.9 times 2 plus 16 times 3, that's 159.7. How many moles are there in 20 grams of... Okay, we've seen this already. This is the wrong question. It was supposed to be this. What is this? What is the molar mass of lead? 207.2 AMU or grams per mole. Where do you find the molar mass of an element? You look for the atomic number. How many moles of chlorine are in 1 mole of CaCl2? As you can see here, the sub value is 2. So there are 2 moles of chlorine in CaCl2. What is CaCl2? Calcium chloride. How many moles of hydrogen are there in 1 mole of the compound NH4 3PO4? Apply distributive property. You apply that rule in algebra in the chemistry context. So where is hydrogen? Over here. So 4 times 3, that's 12. 12 moles of hydrogen in 1 mole of the compound NH4 3PO4. Number 5. Calculate the molar mass of CaCl2. Atomic mass of calcium is 40.1. For chlorine, it's 35.5. 35.5 times 2 plus 40.1, that's 111.1. We've been here before. Yep. Number of atoms. 23 Daltons. 23... Well, if the Dalton value is not the same as the atomic mass unit or molar mass of carbon dioxide, then this is false. Choose the representative particle for diatomic element. Molecule. Okay, recall. Representative particle of element is the number of atoms. Okay, this is worth noting. I'll place this in my list of formulas. Alright. Representative particle of diatomic and molecular compounds is the number of molecules, and the representative particle of an ionic compound is the formula unit. It's all a matter of memorizing these. Diatomic and molecular compounds. Okay, take some time for you to absorb this information, and more importantly, eventually memorize it. Calculate the molar mass of CaCl2. Okay, we've been here before. Mass of 1 mole. Okay. Beryllium. Number of particles contained in a substance. Moles. Yeah. How many moles are there in 8 grams of CaCl3? Okay, so we write down the atomic mass values and we identify the molar mass. So that's not the final answer yet. So we know that 100.1 grams per mole is 1 mole. How about 8 grams? So it's a matter of ratio and proportion. So we know it is implied in this that, let's see, what is the relationship between grams and mole? I am betting that they are directly proportional, because even if, well, we already have the answer, so it is easier to figure out that as the gram value decreased from 100 to 8, so did the mole value. So from 1 to something that's lower than 1, that's 0.079. And it makes sense. The higher the mass, the more moles. So from 0.0879, the closest choice is 0.080. And as you can see, A and B are the same value, but there are different units. How do you know which is correct? Well, we're dealing with moles in the first place. Our final answer was supposed to be in moles, not in grams. So A is correct. Okay. 1 mole of molecules of a substance is equal to the gram molecular mass of the element. Okay. Barium is 137.3 AMU. Nitrogen, oxygen, nothing new. We've already known those values. They've already been stated earlier, so it's familiar to us. Molar mass, just find the sum, 261.35. A compound of nitrogen and oxygen is about 76 grams per mole. Which is its formula? N2O3. Okay, so we're given choices, and we want to see which one matches 76 grams per mole as the value of its molar mass. So we found out that among all the choices, it is A that it was the choice A that matched. So everything else was not equal to 76, as you can see here. And these are the atomic masses to begin with. 200 something, 207.2. Okay. The number of moles is equal to the atoms of that element divided by Avogadro's number. Okay. Avogadro's number of particles holds true for the following. We have ions, molecules, and atoms. Atoms such as hydrogen, oxygen, magnesium atoms. Molecules such as water molecule, as well as ions when they are either positively charged or negatively charged. Cations for positively charged ones and anions for negatively charged ones. The weighted average of the atomic masses. This is the weighted average atomic mass of the naturally occurring isotopes of that element. Okay. True or false? Avogadro's number varies according to the particles in 1 mole of the substance. Doesn't. Okay. Number of particles in a mole is also known as Avogadro's number. 1 mole is equal to, okay, I'll take note of that. Best you do too. Next. 1 mole of hydrogen has the same mass as Avogadro's number of hydrogen atoms. True? Okay. What is the molar mass of sodium carbonate? 106 grams per mole. One way to identify the intermolecular force of a compound or molecule is by looking for its difference in electronegativity. This is directly associated with dipole. So, just to give you a brief definition on what electronegativity is, let me show you. So yeah, this is the electronegativity trend in the periodic table. So go higher and go to the right. Basically, what has at least one of the highest electronegativity values is fluorine because it's located in the uppermost right corner. How about noble gases? I think they're exempted from it. Yeah. So it is implied from this illustration that fluorine has the highest electronegativity. Why do noble gases do not have any electronegativity? They have no need for attracting electrons. They already have a full valence shell of electrons, and they are stable. Well, everyone else isn't stable. It could be implied from that statement. So, okay. Dipole moments occur when there is a separation of charge between two ions in an ionic bond. Ionic bond, by the way, is the bond between two metals. Covalent bond is a bond between a metal and non-metal. Wait. Ionic bond, let me just confirm if I remember it right. Sorry. I made a mistake in what I just said. The bond between metals and non-metals, that refers to ionic bonding. For covalent bond, I believe this is the bond between non-metals and non-metals. Okay, so it is a bond between non-metals. How about the bond between metals and metals? Well, it's called metallic bond, but it's not seen here. Dipole moments arise from differences in electronegativity. The larger the difference in electronegativity, the larger the dipole moment. Something went in my mind. I want to clarify this. Intermolecular versus intramolecular. So from this illustration, intermolecular attraction is basically the attraction between, note the word between. Intramolecular is an attraction within something. There's a specific term for that. I can't be sure. Okay, let's check this definition. Holds atoms together within a molecule. Intra. So this is a single molecule. So atoms here are held together. For intermolecular forces, they exist between molecules. So H and Ci are atoms. They constitute a molecule. Okay, that's well clarified now. True or false? 1 mole of any element contains Avogadro's number of atoms. True. Okay, we've been here before. A mole is defined as that amount of the substance which has a mass equal to the atomic number if the substance is atomic, or the gram molecular mass if the substance is molecular. False? How is it false? There's no explanation. I'll leave it to that. This is matter that has uniform and definite composition. Solid. Just kidding. Substance. Okay, so we are given the molar masses of sodium and chlorine, aka their corresponding atomic masses. We need to identify the mass in grams of 1.50 moles of NaCl. I think we multiply. Wait, no, not multiply. I think we divide it by 6.02 times 10 raised to 23, aka Avogadro's number. Let's check our solution. Nope, we don't involve Avogadro's number here. Ratio and proportion, rather. I think what was done here to get 58.44 was add 22.99 and 35.45. Yep. So you find the sum of the molar masses, and we compare that with 1.50 moles is to how many grams? My only concern is, it might also be your concern. Here the unit is grams, here the unit is grams per mole. Maybe this should have been grams per mole as well, because I'm thinking you can cancel, so moles cancel and we have the grams unit instead in the final answer. Yeah, it does make sense, since we're multiplying 1.50 and 58.44. Okay. So the answer is supposed to be in grams. The mole unit should have been cancelled in the process. So 1.50 moles times 58.44 grams over mole, and the answer is 87.7. And then we have grams as the unit. Okay? Okay, that's not part. This has been mentioned already. Atomic number is the number of protons. Molar mass of iron, 55.9 grams per mole. This is true? Yeah. Okay, so this is what I was talking about earlier. So covalent is the bond between non-metals. Ionic is the bond between metal and non-metal. Metallic bond is the bond between metals. Due to their tendency to form crystals instead of discrete molecules, the formula unit is the representative particle for ionic compounds. Okay, there's no way we could ever see what's beneath these pixelated rectangles. I'm not gonna use pixelation anymore anytime soon. Okay. I think sodium is the metal and the chlorine is the non-metal. What column is, well, what group does chlorine belong to? Let's check the periodic table. So basically everyone here except for hydrogen is a metal. Everyone here, well, at least noble gases and the ones here highlighted as blue, they are non-metals. What's highlighted in yellow here are metalloids. They share properties coming from metals and non-metals at the same time. Anyways, chlorine is here. Charge is negative. Is it negative? No. Wait, is it? Okay, so Na is here, so there's +1, +2, +3, +4, plus -4, -3, -2, -1. Chlorine is -1, and for the noble gases, it's just 0. There's no charge, ionic charge. If I'm not wrong, I think that's how you call it. I think that's what you call it. If only I have my physical reviewers right now, I could point out what I mean better. But the thing is, I can't really find it anymore. precious papers, precious reviewers. Anyways, let's move on. The amount of a substance that contains 6.02 times 10 raised to 23. This is mole. Value of Avogadro. How many moles of chlorine atoms would be present in 1 mole of calcium chloride? 2, as you can see here. Okay, been there, been there, been there. That's easy to do. Again, find the sum. 2 moles of iron, 2 moles of oxygen. Choose the representative particle for the atomic element molecule. So this is the reference. So representative particle of diatomic and molecular, that's already automatically the number of molecules. Molar mass, unit is grams per mole. SI unit, number of particles contained in a substance, that's mole. How many molecules are present in 1 mole of oxygen? So Avogadro's number, molecules are present in 1 mole of oxygen. This is single replacement. Why? So we have, I think this is silver, argentum. That's the old name for silver, coming from the word Argentina. Ag here in the result side, resultant, reactant. Wait a minute. Okay, so the left side is the reactant side, the right side is the product side. So in the product side, it is observed that Ag is well, in a certain way, let's say it got separated or divorced from NO3. NO3 went with Mg, which in the reactant side it used to be single. So yeah, this is single replacement. How many moles are there in 8 grams of CaCO3? Okay, this has already been discussed, as well as this. Calculate the formula mass for, okay, so we're given the atomic masses. How do we answer it? I think we just have to find the sum, right? Yep. So aluminum, we have 2 moles of aluminum, 3 moles of oxygen. Here we have 2 moles of potassium, 1 mole of oxygen, 6 moles of silicon. Is Si silicon? Yeah, I believe it is. Oops. Yeah. And 2 moles of oxygen. Find the sum. Answer is 556.7 U. What is U? It's AMU, but why is it just U here? Maybe it's just an abbreviation of AMU, I think. Okay. Balance the equation. Which of the following is the relative molecular mass of the compound nitric oxide? 30 AMU. So we have nitrogen and oxygen, 14, 16. Nitric oxide is also written as NO. Let me just take note of this. I'm also taking down notes, coming from my own reviewer. Yeah, I believe this may be useful in college, at least for the basic ones, because definitely college chemistry would be a lot more complex. Okay, 14 plus 16, that's 30. Therefore 30 is the answer. Letter A. Okay, KMNO4, potassium permanganate. What is the actual name for this? Yeah, potassium permanganate. So the atomic mass says we have potassium as 39.1, manganese is 54.9, oxygen, we already know that. We identify the molar mass of this substance, this compound. So it turns out to be 158, and we apply ratio proportion. So 158 grams is to 1 mole. How many grams is to 1.50 moles? So applying direct proportion, knowing that grams are directly proportional to moles, we find out that the answer is 237 grams. To be more specific, we put a 0.6 in the end. 0.06. A compound of nitrogen and oxygen is about 76 grams per mole. Okay, that's finished. One blank contains Avogadro's number of molecules, 1 mole. This is, by the way, from Organic Chemistry Tutor. So 1 mole is 6.02 times 10 raised to 23. This is not gram in weight. It is only mole that has Avogadro's number of molecules. Okay, moles would cancel, we have atoms instead in the end. Blank is the smallest particle of an element that still has the element's properties. That's the atom. True or false? There are 33.01 grams of 0.75 moles of carbon monoxide. I think this is just CO. If it were to be CO2, then that's carbon dioxide. Mono is 1, di is 2. That would be false. Why? Okay, so these are the atomic masses. Carbon monoxide is just CO. So 12 plus 16 is 28. And this is not the final answer yet. Ratio proportion. So 28 grams is to 1 mole. 33.01 grams is to how many moles? So we discovered that it was 1.179. It's not equal to 0.75 moles. Therefore, the answer is false. If this were to be 1.179 moles, then the answer would be true. Avogadro's number of particles holds true for... Okay, we've seen this already. Okay. Polar something. No, dipole moment. Okay. Gay-Lussac's law. Just remember, Gay-Lussac is Gay performance task. So performance task, pressure and temperature, they are directly proportional. So therefore, they are written in a way that such that P1 over T1 is equal to P2 over T2. So there's division. Okay. That's it. The representative particle for gaseous nitrogen is the number of molecule. It's not the number of atoms, because gaseous nitrogen is not an element but a compound for some reason. I did note here that I was supposed to ask this to the chemistry teacher, because it did seem a little blurry too for me. Even today. Units of molar mass are grams per mole. Molar mass for sulfur molecule S sub 8. Oh, okay. A sulfur molecule S sub 8. So that's the atomic mass times 8. 256.5. Element The element is the simplest form of matter that has a unique set of properties. Which of the following is a relative molecular mass of P406? 220 AMU. How did we do it? So we have atomic masses over here. Find the sum. 31 times 4 moles of potassium and 6 moles of oxygen. So we have 220 grams per mole. Letter B. The molar mass of iron is 26 daltons. That's false. Molar mass for nitrogen, 14.01. For oxygen, that's 16. Molecular mass of CO2, I'm thinking this is 16 times 2, 32. Yep, that's correct. Charles' law, just remember Charles' vendetta, VT, vendetta. V is volume, temperature is T. So, just like in Gay-Lussac's P over T is equal to P over T, in Charles' law, it's V over T is equal to V over T as well. The similarity is that, well, volume and temperature are directly proportional, so therefore we divide them in this fashion. You can actually swap them, I think. So if in the left side it's T over V, the right side should also be T over V. It's similar to Gay-Lussac's pressure and temperature because pressure and temperature are also directly proportional. A mole is defined as that amount of the substance which has a mass equal to the atomic number if the substance is atomic, or the gram molecular mass if the substance is molecular. False. Law of conservation of matter. Matter is not created or destroyed. Whether there is physical or chemical change, the mass of the reactant is equal to the mass of the product. For a while. Okay. In whether there is physical or chemical change, regardless, the mass of the reactant is still equal to the mass of the product. So in a chemical equation, again, the reactant is in the left side and the product is in the right side. So masses do not change. In physical change, substances can change form, but the total mass will remain the same. In chemical change, the net mass of the reactant is equal to the net mass of the product. I think in chemical change, the chemistry of a particular matter can no longer be reversed to its previous form. For example, burning paper. But perhaps the mass is still the same. I think that's the idea here. For physical change, for example, an ice cube is equal to 500 ml. It's a big ice cube. You turn it into liquid form, it's still technically 500 ml. The mass remains the same, but the substance is different in terms of form, physical form. True or false? 1 mole of any element contains Avogadro's number of atoms. That's true. Blank is matter that has uniform definite composition, substance. Molar mass of iron, we've already seen that. Avogadro's number is a dimensionless quantity. What do you mean by dimensionless quantity? Okay, so dimensionless quantity means a quantity which is independent or does not have physical or fundamental units. I believe this has something to do with the idea that Avogadro's number is just a constant. It's not influenced by other factors. which changes its number. I'm not sure. Let's move on. Okay, we've seen this already. Which of the following elements has a molar mass of 19 grams per mole? Oxygen is 16, neon is not sure. Fluorine is, well, it's already stated here that the molar mass or atomic weight is 18.998 or approximately 19. Phosphorus, okay, we only have the molar mass for fluorine. The other choices, I guess I didn't place them there. Okay, that's it for this video. We finished the Anki deck. Yeah, thanks for watching. I'll see you soon in the next chemistry video.